Good morning, guys. We are busy with business literacy, and now we are starting in Module 2 with numeracy. And Module 2 is all about working with numbers. What I've done is I've divided it into 5 parts, and in this lesson, I'm going to look at Part 1, Introduction to Numbers. Okay, let's have a look at the properties of numbers. Now, when I say properties of numbers, I mean the things that make numbers numbers. So when we talk about numbers, what are we talking about? First thing, numbers have a value. Okay, the value is determined by the number's position. So you see there on the right-hand side, I've got the same 3 digits, 001, but depending on the position of the 1, the value of the number changed. If it's 001, it just means 1. If it's 010, you know it means 10. And if you see a 1 or 2 zeros, you know it means 100. Secondly, the value is influenced by a sign. So -1 will always be less than 1. And +1 and 1 is the same thing. So when a number is positive, we don't give it the positive sign, we just leave it as is. Then secondly, numbers have a symbol. So we don't write out the word 1. We simply use the symbol 1. The same for 2 and the same there for -1, as I've showed you there on the right hand side. And then thirdly, numbers are used to calculate. So there you have a very simple calculation. It says 1 + 1 = 2, and I've given it to you in words there as well so that you can understand. So let's just have a look at it again. Numbers have value, numbers have a symbol, and numbers are used to calculate. Those are the properties of numbers. Now, we get different types of numbers. Okay, so we get rational numbers and we get irrational numbers. Now, we are not going to look at irrational numbers too much in this course, but we will look at some of them. We will have a look at non-terminating and non-repeating decimals, but even then we are going to round them, so you don't have to worry about irrational numbers too much. But when we talk about rational numbers, we really start with the natural numbers. Now, why do we call them natural numbers? Because when you grow up and you learn to count, you start by counting with the natural numbers. You say 1, 2, 3, 4, 5, 6, 7. All of those are natural numbers. Then, after a while, because your parents say no to you when you want things that they don't want to give you, you are introduced to the concept of 0. And then you realize, okay, so there's a 0 as well. And then our thinking when we count with the whole numbers is more 0, 1, 2, 3, 4, 5, 6. So the whole numbers include all the natural numbers plus 0. That's the only difference. Then we get to integers, and we are going to work a lot with integers in this course, is where you have the whole numbers plus all the negative numbers. Okay, and in integers can either be even or they can be uneven, and I already said they can be positive or negative. So when you look at even integers there, I've given you some example: -4, -2, 2 and 4. If we're looking at uneven integers, we are looking at -3, 1, 1, and 3. Okay, so those are the integers, and we are going to have a look at them shortly. Then we also have a thing there called rational numbers. Now, rational numbers include the integers, the fractions. Okay, fractions is anything over something else. We'll see that later. The terminating decimals, so 0.2, that's a terminating decimal. And then also the repeating decimals, where we put the little dot on top and it becomes 0.33333, and instead of writing 3 into infinity. We just put a little dot on the 3, and it means that it is 0.3 repeating itself. And if you know that, you realize I'm talking about a third. Okay, now we are, sorry about that, guys. We are getting to the number lines. So first little number line there on top is an integer number line. Okay, the integer number line in this case, I've given you little arrows on each side of the line so that you can see it continues. But on this line, I started with -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5. Okay. And the negative numbers get smaller to the left, and the positive numbers simply get larger to the right. So the bigger the value of a negative number, the smaller that number actually is. So for instance, -10 is smaller than 5, but when we have positive numbers, the bigger the number gets, the larger it is getting. 5 is obviously bigger than 1. Then the second number line I've showed you there underneath is the decimal number line. Now the decimal number line just goes from -1 to 1. Okay, and what I'm showing to you there is that there are infinite decimal points between following integers. So I've just given you the quarters there, 0, 0.25, 0.5, 0.75, and their negatives. But really, in between any of those decimals, I would be able to add another decimal. So that's why we mean infinite, means it doesn't stop. There are infinite decimal points between following integers. And the number lines are always divided in increments. So increments just mean that the spaces on the number line represent the same value. So if you look at the one at the top, the integer number line, the increments there was 1. But if you look at the decimal number line at the bottom, the increments are a quarter. Now let's hope that we don't have funny sounds on this one as well, but I'm not guaranteeing anything. Okay, nothing happened. Glad to see that. Now, we also get different number systems. Now, the number system that we are used to is, of course, the decimal system. It uses 10 symbols, and you know those 10 symbols. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0. And when we see a number that is using the symbols 1001, we read it as 1001, because that's what we know. It uses 10 as its base number. Now, we don't put the base number 10 down every time, but really that is what it is. So we just use the symbols 1 to 3 up to 9 and 0. Okay, and we read it, remember, as 1001. Now, there's another system, another number system that we are going to use in this course, and I'm going to do this in part 5 of module 2, and that is called the binary system. Now, the binary system is the system that computer scientists use, and it forms the basis of any computer language. And it has only 2 symbols, and these 2 symbols are 1 and 0. Now, if we take that same sequence of digits that we had in the decimal system, the 1001, we read it as 1001. Okay, and it uses 2 as its base number. Now, when you get to a test or an exam with the ICB and they put down that number, a number that only consists of 1s and 0s, how do you know whether it is the binary number 1001 or the decimal number 1001? Well, they will do the following. At the bottom here of this one, they will put a little 2 to show it's binary, and if it's decimal, they will put a little 10 at the bottom of this one. Why? Because decimal uses 10 as its base number, and binary uses 2 as its base number. Don't worry about the binary too much. I'm going to show you that much later. Other common symbols that you are going to encounter is that little figure 8 that looks like it's been turned on its side, and that means infinity. So there are infinite positive and negative numbers. It means we can always add another negative number. We can always add another positive number. It doesn't stop. That's what it means. Then you see the little arrow pointing to the left there. That means smaller than. And the little arrow pointing to the right means larger than. You've encountered this at school. This is nothing new to you. For example, -1, then the little sign 0 means -1 is smaller than 0. And then if you have the positive 1, now the other arrow 0 means 1 is larger than 0. And it's important that when you do maths, you read it correctly. Okay, so they are the, I would say, 6 of the most common ones we use: the plus, the minus, the multiplication, the divide sign, the equal sign, and the not equal to sign. Okay, you know them already. You've used them your entire life. You press them on calculators all the time, so there's nothing new there. Now we get to something interesting. It's notation. Now we get short and long notation, and it is used to express numbers of 1 million or greater. And then depending on the situation, South Africa uses both scales. Now, mostly in English, we use the short scale, where every term is 1,000 terms bigger than the previous term. So when you talk about 1 billion, we are referring to 1,000 million. And when we talk about 1 trillion, we are talking about 1,000 billion. Each term is 1,000 times bigger than the previous. But with the long scale, if we use the same words, we mean something completely different. Then 1 billion is 1 million, and 1 trillion is 1 million billion. Problem in South Africa is that different languages might use different scales, but basically we are going to use the short scale, and you're going to see that on the next page. So for example, 7 quadrillion and 1 will be written as a 7 there with, what is it, 14 zeros and a 1. Okay. And then there's an example there. It comes out of an old test, something. Find x in the following case. 1 trillion is x to the power what? And then we simply count the zeros, and we will say that it is 10 to the power 12. We are going to look at powers a little bit later as well. So also not something to worry about now. But to explain short scale notation a little bit better to you, there it is. So you have a number. You can write that number to its base 10, because remember the decimal system uses 10 as its base. Then that number has a name, and there is a basic logic to its power notation. So let's take 1. 1 is 10 to the power 0. That symbol has a name. Its name is 1. And the basic logic for its power notation is that a 1 has no zeros. Okay. Let's go and look at the number 10,000, for instance. 10,000 we write as 10 to the power 4. And the basic logic is that there is 4 zeros in 10,000. So it is 10 to the power 4. Same if we look at a million. A million, it's got 6 zeros. Because it's got 6 zeros, we're going to write it as 10 to the power of 6. And that's the end of this part. So thank you, guys. It was good speaking to you. I'm going to stop my share screen, and then we can get into part 2 when we meet again. Thank you.